Hey everyone, and welcome to today's Explainer. We have got a seriously cool project lined up today, one that perfectly captures that absolute magic of radio history, combined with the pure joy of just getting on the workbench and making things work. We're going to be following the journey of Pete Giuliano. You probably know him in the amateur radio community by his call sign N6QW. We're tracking his really ambitious quest to build a classic, vintage CW transmitter. That's continuous wave, which is essentially Morse code. But here's the twist. He's doing it as a modern testbed build in May of 2026. It's just a brilliant story about taking this incredibly old technology and functionally bringing it right back to life today. Okay, let's dive into this. To really understand this project, you have to look at Pete's core motivation. As he put it himself, I decided to relive the days of old by building some CW transmitters. You see, Pete was first licensed way back in 1959. That was an era where vacuum tubes weren't a novelty. They were the absolute standard for radio communication. And what's so fascinating here is seeing that deep, decades-old knowledge smash right into today's modern maker culture. Pete isn't just taking the easy route and buying off-the-shelf plug-and-play gear to get on the air. No way. He is meticulously recreating the golden age of radio on his workbench. We're talking wooden boards, painted front panels, and a whole lot of creative problem-solving. It's like a giant puzzle connecting nearly a century of radio history straight to this modern build. Let's trace that lineage for a second. We start way back in the 1930s, an era when the 6A6 oscillator basically ruled the roost. It was the absolute go-to for a really efficient low part count circuit. Fast forward a bit to August 1947, and QST magazine publishes their famous Last Ditcher article, showcasing these incredibly bare-bones designs to the whole radio community. Move ahead to 1959, and that's when Pete gets his first amateur license, cutting his teeth on these exact types of vacuum tubes. And that whole timeline brings us right to May 2026, culminating in Pete finally deciding to build a modern testbed for these vintage circuits. Section 1. Early trials and tube tests. Because, as we all know, trial and error is absolutely the heart of any good maker's journey. You rarely hit the nail on the head on the very first try, right? Before tackling that legendary 6A6, Pete ran some preliminary experiments just to see what it was actually like working with vintage tubes today. First up, he tried the 1J6GT. Now, this is a dual triode tube, very few parts, and it looked fantastic sitting there on a breadboard. But there was a catch. To run properly, it requires a completely goofy power supply. We're talking 2 volts DC on the filaments at 1/4 of an amp, plus 135 volts DC on the plates. Pete actually managed to build that complex supply, but the test results? Well, in his own words, he was less than overwhelmed. Realizing that wasn't the way to go, he smartly pivoted and started testing the 6V6 tube instead, pairing it with a P-network output, which, for a quick refresher, is basically a filter and impedance matching circuit that efficiently transfers energy from the tube to the antenna. And wow, did that pivot pay off? That 6V6 build pumped out a highly respectable, totally rock-solid 1.3 watts of output power on the 40-meter band, using 280 volts on the plate. This was the proof of concept he needed. It proved for sure that a clean, highly functional vintage transmitter could definitely be built and optimized right there on a modern testbed. So, with a win under his belt, Pete was ready for the main event. Section 2. The 6A6 Jones Oscillator. So the 6A6 is this classic 1930s circuit, famous for its extreme simplicity and incredibly low part count. It's the perfect target. But, of course, the maker's journey never goes exactly as planned, and disaster struck in the form of online shopping. Pete admits, and I quote, "I ordered the wrong socket." Look, if you've spent any time at a workbench, you absolutely know that universal pain. You order what you think is the right part, and you only realize you messed up when it's literally in your hands. The 6A6 tube needs a 7-pin medium socket, but because there are a bunch of sizes, miniature, small, medium, Pete accidentally bought the 7-pin small. So he had this beautiful vintage tube and a base it absolutely could not plug into. Once he finally got his hands on the correct 7-pin medium socket, he had a whole new headache. The footprint was way bigger, so the available space on his existing circuit board was pretty much zero. So what does he do? He pulls off this brilliant little maker hack. First, he just mounted the medium socket right on top of the insulated side of his PC board. Then, to make the connections without having to tear down and rebuild the entire testbed, he simply drilled holes straight through the board. From there, he ran his wires from both above and below the surface. It was a massive space saver, and get this, it worked perfectly. It's just a fantastic example of taking a frustrating mistake and turning it into a really clever workaround. Section 3. Testing, tweaking, and warnings. Now, what's really interesting about this slide is how Pete approached the actual testing of the 3-crystal position rig. Okay, so Pete's got the 6AA6 mounted, the rig is ready for power, but this is exactly where vintage documentation severely clashes with modern reality. I need to be really serious for a second here. If you dig up the original 1930 schematics for this oscillator, they clearly tell you to run it at 400 volts DC. Pete is incredibly clear on this. Do not do that. If you hit this setup with 400 volts today, you will blow the tube. Poof. Gone. You absolutely must keep it to a maximum of 300 volts, maybe carefully inching up to 320 at the absolute most. This is just a crucial piece of modern testing correcting historical docs, and honestly, it's going to save a lot of builders from ruining some very rare vintage glass. So, what actually happens when you safely run this thing at 300 volts? Pure magic, honestly. At that reduced safe voltage, Pete pushed out a remarkably clean 1.5 watts of signal on the 40-meter band. But here is a truly mind-blowing part. That tiny 1.5 watts gave him an incredible reach of about 600 miles. Let that sink in for a second. 600 miles. It completely proves you don't need to push these delicate components to their dangerous schematic limits to get phenomenal long-distance performance. Section 4. Replication Tips. Let's get into the nitty-gritty for a second. If you are watching this feeling inspired and thinking about heading to the workbench to build this yourself, Pete gave us some highly specific, actionable advice. First up, the dual-section capacitor. Pete originally tried a 100 PF version, but he found it was almost completely meshed, meaning the plates were too overlapped, and it ruined his tuning range. He strongly recommends bumping that up to a 150 PF per section capacitor so you have proper tuning room. Second, for the link coupling, which is just how you transfer energy out to the antenna, you literally only need one turn of wire. However, link coupling is notoriously prone to throwing off unwanted radio noise or harmonics. Because of that, adding W3NQ low-pass filters is absolutely mandatory to keep your signal clean and legal. And finally, don't sweat trying to build some goofy vintage power supply from scratch. Pete points out you can grab a perfectly capable modern unit right off Amazon for about $30 that will cleanly power the whole shebang. So when we pull back and look at the big picture, the benefits of this build are really striking. We're looking at a transmitter with a ridiculously low part count. It's genuinely accessible thanks to cheap, modern power supplies and clever hacks. It's very low cost, yet it reliably pushes out a clean 1.5 watts that can bridge 600 miles. Because of that rare combo, simple, reliable, cheap, this nearly 100-year-old circuit is actually an exceptional tool for emergency communications right now. Which leads us perfectly into Section 5, Emergency Rigs and POTA. You might be wondering, why does a 1930s vacuum tube oscillator matter in the 2020s? Well, it matters deeply because of things like POTA, or Parks on the Air. If you don't know, POTA is this hugely popular activity where ham operators take portable gear out into national and state parks to make contacts. Pete describes taking this specific 6A6 vintage build out into the field for POTA as, quote, the bomb. And think about it, it makes total sense. It's lightweight, uses minimal parts, powers easily off a small modern supply, and it connects you directly to the profound roots of radio history while you're just sitting outside in nature. It completely bridges that gap between the days of old and modern active radio operation. So, as we wrap up, I want to leave you with a question. Do you have an emergency rig you can put together? Pete Giuliano absolutely proved that you don't need complex, expensive modern microchips to build a highly reliable 600-mile transmitter. Sometimes looking backward at the sheer brilliance of 1930s engineering is exactly the spark a modern maker needs to build something truly special. I really hope this explainer got you curious. Maybe curious enough to fire up the soldering iron, hunt down a few vintage tubes, and try it out for yourself. Thank you so much for joining me today, and in the great tradition of amateur radio, 73s.